All right, we have a pipeline that we're connecting 2 points across the river from each other. So let's go ahead and sketch what we've got here. We've got our river, okay, and we'll say there's our point A, and then on the opposite bank, our point B, and we know the river is 2 miles wide, so that's 2, and then they are 7 miles apart. So from here to here, that's 7. And we're going to build the pipeline underwater from A to some point C on the opposite bank. So we'll call that C. So there's our pipeline, and then from C all the way down to B. All right, so that's a sketch of what we're doing here. So we need to find a cost function so that we can minimize the cost. Well, cost, let's say that the cost of running across the ground is, or above ground I should say, is just K. So K dollars per mile, that's the cost above ground. And then of course underwater is 4 times that, so 4K. So the cost from C to B, okay, well that distance, we'll just call that distance X. Actually we'll call that 7 minus X, and then we'll call the distance from A to there, we'll call that X. Okay, so and now we can create a little triangle. Okay, that's 2. And then this distance here, we can find that by the Pythagorean Theorem. That's just the square root of 4 plus x squared. Okay, so now the cost, well, the cost across land, that's just the K dollars per mile times the 7 minus x distance, and then plus the cost underwater is 4 times K, and then times that distance, square root of 4 plus x squared. And that's what we're trying to minimize. And it's already in terms of one variable. K is just some fixed constant. And so we can now take the derivative of it. So we have K times the derivative of 7 minus x, which is negative 1. And then plus 4K, and then taking the derivative square root, we have a power of 1/2, which we pull down. And we have 4 plus x squared to the negative 1/2. And then times the derivative of 4 plus x squared, which is 2x. All right, so we can simplify this. We have a negative k plus, this is going to be 4kx. Notice the 1/2 and the 2 will cancel. So we have the x. And then 4 plus x squared to the negative 1/2. And we'd like this to equal 0. Well, notice if we can divide everything by k, and that'll just get rid of it for us. So we have negative 1 plus 4x, 4 plus x squared to the negative 1/2 equals 0. And now we'll add the 1 over. So 4x, we'll write this as a fraction now, over 4 plus x squared to the 1/2 is equal to 1. Which means that 4x needs to equal 4 plus x squared to the 1/2. And we can simplify that now by simply squaring both sides. So we get 16x squared equals 4 plus x squared. Alright, so we can subtract the x squared over. We get 15x squared equals 4. So x squared equals 4 over 15, and then take the square root. So x is, well, plus or minus 2 over root 15. However, we need to make sure that which of these two it can actually be. Notice that x being negative, that would mean that we go backwards. That's certainly not going to give us a minimum cost. And so we actually have x equals positive 2 over root 15. And now all we need to do is make sure that this actually does give us a minimum cost. And so we can use our first derivative test again. So our first derivative is 4kx over the square root of 4 plus x squared, and then minus k. And we'll go ahead and factor the k out. So that times k. That's our first derivative. And now we just need to look at a number line and see if we're see what happens with our first derivative. So we have 2 over root 15. Let's go ahead and plug in 0 for x. Plug in 0, you get 0 minus 1 is negative 1 times k, which is definitely going to be negative, so we're decreasing. And then plug in a bigger number. Say plug in 2, you get 8 over the square root of 8, which is the square root of 8, minus 1, and that's going to be positive, so we're increasing. So we do get a minimum there at 2 over root 15. And that tells us the location of C that will minimize the cost. It just needs to be 2 over root 15 miles downstream from A.